All right, let's make an answer key for some of these practice questions, starting with question number 1. So I need to simplify this expression right here. So when I'm taking a look at a question like this, I notice that there's 2 times 2. So 2 times 2 is 4, and 5 times 5 is going to be 25. So this is the same thing as 4 times 25, all under the square root sign. And after that, you can just take the individual square roots. So what's the square root of 4? The square root of 4 is 2. And the square root of 25 is 5. So this is really the same thing as 2 times 5, which is 10. So for question number 1, the answer is 10. Okay, let's move on to question number 2. I need to simplify this expression here. So if I take a look at this part of the question, the square root of 1, well, the square root of 1 is just positive 1. And then you have this minus sign on the outside, so that just tags along. And then you have a plus sign, so the plus sign will tag along. And then finally, there is the square root of 7 squared. There's 2 ways where you can think about this. If you think about the quicker way of doing this, we talked about that the square root sign and the power 2, it just cancels off, giving you just 7 as the final answer. Or ask yourself, what is 7 squared? Well, 7 squared is 49, and the square root of 49 is 7. So you will add plus 7 to that. So negative 1 plus 7 is the same thing as 6. Okay, let's move on to question number 3. 3 is a little bit different because of this plus sign here. So go ahead and evaluate the numbers here. So what is 3 squared, right? So 3 squared is 9 plus 4 squared is 16. And 9 plus 16 is going to be 25, and the square root of 25 is going to be 5. So the answer is A. Okay, let's move on to question number 4. What integer is negative root 70 close to? Okay, so for this particular question, I would think of perfect square numbers. So for example, 8 times 8 is going to be 64, and I know that 9 times 9 is going to be 81. All right, so why are those expressions important? Because if I take the square root of 64, we know the answer is 8. Okay, so let's just put the square root of 64 over here, a perfect square root, and if I take the square root of 81, that's 9, right? So let's put the square root of 81 over here. And the question is, we have root 70, right? So root 70 is kind of in the middle there, right? So we know the square root of 64 is going to be 8. I know the square root of 81 is going to be 9. So therefore, the square root of 70 is going to be between 8 and 9. Okay, the way I see this is from 64 to 70, that's a difference of 6. And from 70 to 81, that's a difference of 11. So is 70 closer to the 64 or the 81? Well, 70 to me is closer to the 64, so this could be approximately 8.4. And since these are all negative, you can put the negative signs on the outside. So negative 8, and negative sign there. So roughly I have negative 8.4. And so basically, if we evaluate this, which one of these answers are closest to negative 8.4? So I would probably say it's going to be answer B here, negative 8. All right, so we don't round this up to negative 9, right? Because it's 8.4, negative 8.4. So I think negative 8 would be the best answer here. Okay, so move on to question number 5. So I need to evaluate this. Okay, not too bad. Let's do the brackets first, because in bad math we always do the brackets first. Okay, so 6 squared is going to be 36 minus 2 to the power 4 is going to be 16. So this is going to be 36 minus 16 minus, and then we have 4 times 2, and 4 times 2 is going to be 8. Okay, so then we just now compute what's in the brackets here. So 36. So 36 minus 16 is going to give us a nice answer of 20, and 20 minus 8 is going to be 12. So the final answer here is going to be 12. Okay, so hopefully that one wasn't too bad. Okay, let's move on to the next one here. Which of the following expressions is equivalent to 8 to the power 5? Okay, so for this question here, you have to focus on the 8. The 8. All right, so what we need to do over here on the side is let's go ahead and evaluate expressions with the base of 2. So 2 to the power 1 is going to be 2. I know that 2 to the power 2 is going to be 4. And I also know that 2 to the power 3 is going to be 8. So this these side calculations over here in this red box are very important because this is the expression you need. You need to know that 2 to the power 3 is 8. So instead of writing an 8 here, I can write this as 2 to the power 3. And I'll put that in brackets. And then you have this 5 that's hanging around. So let's put the 5 over there. And if you follow your exponent rules, 3 times 5 is going to be 15. So this will be 2 to the power of 15. Okay, so the answer there is going to be A, 2 to the power 15. All right, so you definitely need to know your powers, starting with a base of 2, so 2 to the power 1, 2 to the power 2, and 2 to the power 3. So if you understand that, that's a good place to kind of get this question started. Okay, let's move on to question number 7. Which of the following is not equal to 1? All right, so a great question here. Let's start off with B here. So I noticed the top and the bottom of this fraction are the same, right? So if you have the same number divided by the same number, that's always going to give you an answer of 1, right? So the same number divided by the same number, that's always going to be 1. Okay, let's take a look at D next. If I have 2 minus 3 in the brackets, well, 2 minus 3 is going to be negative 1 to the power 0, and anything to the power 0 is always going to be 1. So D is also equal to 1. Okay, let's take a look at C here. So I know 0 to the power 4, well, that's going to be 0. And I also know that 4 to the power 0, just 4 to the power 0, that's going to be a 1. Okay, and since we have a minus sign there, this will be negative 1. So negative 1 plus 0 is going to be negative 1. Okay, so from that, C will be the answer. C does not equal to 1, but let's go ahead and do question number 7 here, or 7a. So if I take a look at the brackets here, remember we always do brackets first with BEDMAS. So negative 1 to the power 5. I mean, if I think about that in terms of expanding it, that's the same thing as negative 1 times negative 1 times negative 1 times negative 1 times negative 1. And then you have this negative sign on the outside there. Okay, and if we count up all the negative signs, there's 1, 2, 3, 4, 5, 6. So 6 is an even number, so the answer will be positive, and 1 times itself 5 times will be 1. So there you go. This equals to 1, that equals to 1, this equals to 1, and this answer here, that does not equal to 1, so the answer is going to be C. Okay, let's move on to question 8 now. Question number 8, I would start off by putting a 1 here. So 7 to the power 1 there. And let's go ahead and evaluate the brackets, right? So if I evaluate the brackets there, that's really, we have 7 to the power 3 times 7 to the power 1. So if the bases are the same, we just add the powers, right? So 3 plus 1 is going to be 4. So this is really 7 to the power of 4. So let's change this to 7 to the power 4. And then we have times, and then we have this thing here, which is 7 to the power 2. And we have 7 to the power 8 over here, 7 to the power 8. Oops. And then we have the division sign there as well. Okay, so this is looking pretty good here. Now, it doesn't really matter about the order here, but let's go ahead and just take care of this first. If we're multiplying, and the bases are the same, we just add the powers. So this will be 4 plus 2 will be 6, right? And then we still have this 7 to the 8 divided by that. And this is really the same thing as 7 to the power of 8 divided by 7 to the power 6. And if the bases are the same, and if you're dividing, you're subtracting the powers. So finally, we just do 8 minus 6 will be 2. So 7 to the power of 2. And that's it for question number 8. Question number 9 here, you have to be very careful because there's a plus sign here, so we're not using any exponent rules. You just need to be very good at computing these. So I have negative 2 to the power of 4. So if you had to expand that, that's the same thing as negative 2 times negative 2 times negative 2 times negative 2. And if you multiply all that out together, you actually get 16. You get 16 there. All right, and then because you have a plus sign here, this is a different kind of problem because there's an addition sign, right? So now you have to add. Then you have negative 2 to the power of 2. So that's going to be negative 2 times negative 2. And negative 2 times negative 2 is going to be positive 4. All divided by Well, we have this expression here, negative 2 to the power 3. So if you're not sure about your expressions here, always expand. All right, so what's in the brackets? It's a negative 2, right? So negative 2 times negative 2 times negative 2. This is going to be negative 8. So on the bottom here, we have negative 8. Okay, now we need to just finish this off here. So 6 plus 4 is going to be 20, divided by negative 8. And 20 divided by 8, we just have to reduce the fraction there. So if I reduce this fraction, that's the same thing as a negative, and then 5 over 2. Just divide top and bottom by 4. All right, so just divide top and bottom by 4, and you'll get negative 5 over 2. And just remember, this minus sign right here, you can just move it to the top there if you like. So negative 5 over 2 is going to be the right answer. Okay, so move on to question number 10. Write in exponential form. All right, so this one's not too bad. Let's take a look at this yellow expression here, which is x to the power 3, and then you have a 4, right? So all you're doing here is just multiplying the 3 and the 4. If I do that, 3 times 4 is going to be 12. And then you have this bigger bracket on the outside, and you have that 5 here, right? And 12 times 5 is going to be 60. So x to the power of 60 is your final answer for question number 10. All right, for question number 11, now my bases here are 4 and 4, right? So make sure you know the difference between a base and the power. The powers are x plus 2 and x minus 2. Now, if the bases are the same, which they are, the bases are 4, and if you're dividing, you need to subtract the powers. So you're subtracting the expressions in green there. So let's start off with writing the base of 4. And then your first power is going to be this x plus 2. And then as I mentioned, you are subtracting, right? You're subtracting, right? But what are you subtracting? You are subtracting this bottom expression, which is x minus 2. Now the key with that is you do have to put that in a bracket because there's 2 terms there. And then for math 8, you probably remember your teacher going through the distribution property there. So that's going to be negative x. And then a negative times a negative is going to be positive. So positive 2. And then you have this x plus 2 in front. And then all this is being raised to the power 4. Okay. All right, so what is x minus x? Well, x minus x, that's just going to cancel off, right? So if you have one x box, and if you lose another x box, you have no x boxes. And then you have a plus 2 and a plus 2, which is going to be 4, right? So 2 plus 2 is 4. So your final answer is 4 to the power of 4. And that's going to be answer 11A. Okay, let's move on to question number 12 now. All right, for this one here, I will highlight the powers of 0 first. So 5 to the power of 0 is going to be 1. And this 5 to the power of 0 is going to be 1. And the minus signs, they just tag along. So minus 1 is going to be negative 2, which is D. Okay, let's move on to question 13. For question number 13, I would do the brackets first. With BEDMAS, always do the brackets first. All right, so then I notice that the base here is 9 and a 9. If the bases are the same, you just subtract the powers. So what is 8 minus 2? 8 minus 2 is going to be 6. And then you have this 3 that's hanging on the outside, and now you just multiply the powers there. This will be 9 to the power of 18. That's it. All right, let's go to question number 14. What I noticed is that we have powers and powers, so 4 times 2 is going to be 8, so b to the power of 8 times, and then this right here is just b squared. And now if you're multiplying and if the bases are the same, you just add the powers. So what's 8 plus 2? 8 plus 2 is going to be 10. There you go. Okay, for question number 15, I noticed that the bases, I'm just going to blow this up on number 15 here. For number 15, I notice that the bases here and here, the bases are the same. And if the bases are the same, and if you're dividing, you need to subtract the powers, right? So the base here is going to be negative 5. And you are subtracting the powers, so 7 minus 4. And if we do that, we have a negative 5 to the power of, well, 7 minus 4 is going to be 3. Now for this question here, to finish this off, I would just expand this, right? If you're not sure what the final answer is, just always expand using your power rules. and it's just really -5 times -5 times -5. Now, because you have an odd number of negative signs, that's going to be a negative. And then ask yourself, well, what's 5 times 5? 5 times 5 is 25, and 25 times 5 is going to be 125. So the final answer is -125. Okay, let's keep on going here. Simplify the following. All right, let's do the brackets first. What's 2 minus 3? Well, 2 minus 3 is going to be -1, all to the power of 100. Now, since this is an even number, it's an even power there, so it's like -1 times itself, an even number of times, so that's just going to be +1. Over here, I noticed that the bases are all the same. If the bases are all the same, and if you're multiplying, you just add the powers. So what's 0 plus 1 plus 2? Well, 0 plus 1 plus 2 is going to be 3. So the final answer is 3 to the power 3, and 3 to the power 3 is going to be 27. Okay, let's move on. Okay, so the classic Pythagorean Theorem question. So at the front of this assignment, the Pythagorean Theorem was given to you as a squared plus b squared equals to c squared. So usually this is something that you cover in the Math 8 curriculum here. So remember, the a's and the b's, those are the legs of the triangle, and c is the hypotenuse. So the hypotenuse here is going to be root 17, right? So this is your hypotenuse. So it's going to be root 17. And then you're going to square it. And then you have your 2 and your x. Those are going to be your a and your b values. The order doesn't matter, right? Because 2 plus x is the same thing as x plus 2. So if you want to write this as 2 squared plus x squared, you can do that. And this is just kind of testing you if you know your powers. So 2 to the power 2 is going to be 4. X squared, you really can't do anything with that right now, so I'll leave that as x squared. And then on the right hand side, one thing that we are testing is if you have a power 2 and a square root, what happens? Well, they cancel each other out, so you get a 17. And then over here, this 4, you can minus 4 from both sides. So you have x squared equals 2, and now you have 17 minus 4, and 17 minus 4 is going to be 13. And then from here, if you want to get rid of this power 2, you got to square root both sides. So x would equal to root 13. All right, so that's it for that particular question. Just a Pythagorean Theorem question with some square roots and powers. Okay, let's move on to the next few questions here. All right, so simplify. Now we're getting into some harder questions here. For this question here, it's probably best to start working with the power on the outside here. So just go backwards here. So 3 times 4 is going to be 12. So c to the power 12. And then 3 times 2 is going to be 6. So that's going to be b to the power 6. So you multiply the powers. Now, just before that, I do want to say that we're kind of done with the b and the c, right? We're done with that. And if you notice very carefully, there's a 2 here and a 3, right? So really, you have to evaluate 2 to the power 3, right? It's really 2 to the power 3. And 2 to the power 3 is going to be 8. So I'll put an 8 there. And then I'll put a bracket there and a bracket there and a 2. And finally, 2 times 8 is going to be 16. So 16, b to the 6, and c to the 12. That's your final answer there. So 16, b6, c12. All right, let's move on to letter B here. Focus on the top first. And from that top, notice that the bases here are x. If the bases are the same, and if you're multiplying, you just add the powers. So what's 6 plus 5 plus 4? Well, 6 plus 4 is 10, and 10 plus 5 is going to be 15. So x to the power 15 divided by x to the power 3. Now, if the bases are the same, and if you're dividing, you just subtract the powers. So 15 minus 3 is going to be 12. So x to the power of 12. Okay. All right, let's move on to C now. C, we're just multiplying straight up. So I would multiply the numbers with the numbers. So here's a 3 and a 2. So 3 times 2 is going to be 6. And then multiply the letters with the letters. So I have a to the power 2 times a to the power 6. So once again, on the side here, that's a to the power 2 times a to the power 6. If the bases are the same, and if you're multiplying, you just add the powers, right? So what's 6 plus 2? Well, 6 plus 2 is going to be 8. So it's a to the power of 8. So a to the power of 8. And finally, I have b3 and b4, right? So it's really b3 times b4. So if the bases are the same, you just add the powers. So there's a b to the power of 7. So b to the power of 7. And that's your final answer there. Okay, let's move on. 15s. These are some also good questions. Whenever you see brackets, my recommendation is you always attack the brackets first. Okay, so inside the brackets, there's an 18 and a 3. Well, what's 18 divided by 3? 18 divided by 3 is going to be 6. Okay, and then x to the power 7 divided by x to the power 2. If the bases are the same, and if you're dividing, you subtract the powers, right? So what's 7 minus 2? Well, 7 minus 2 is going to be 5, so x to the power 5. And after that, there's a y to the power of 4 divided by y to the power 3. If the bases are the same, and if you're dividing, you subtract the powers. So 4 minus 3 is going to be 1, so y to the power 1. Okay, and after that, you have this outside 2 that's still hanging around. All right, and then after that, you can just go backwards and multiply now. So 1 times 2 is going to be 2. 2 times 5 is going to be 10. And then if I get rid of all that, notice that I have 6 to the power 2 now. Well, 6 to the power 2 is really 6 times 6, which is 36. All right, so don't make the mistake of leaving the answer as 12. Like, don't do 6 times 2. It's really 6 to the power 2, which is 36. Okay, let's move on to the next one here. So we do brackets first. Okay, so there's really an invisible 1 and a 1 there. So if I go backwards here, that's going to be c to the power 3. And that'll be b to the power of 3. And then 3 times 2 is going to be 6, right? So a to the power of 6. And then if I erase all the letters because I'm dumb and all that, notice that we now have a 3 here and a 3 there. That's really 3 to the power of 3. A 3 to the power of 3 is really 3 times 3 times 3, which is 27. So there's a 27 there. All divided by the bottom, which is 3 a to the 4, b to the 3. All right, then from here, divide the numbers with the numbers. So what's 27 divided by 3? 27 divided by 3 is 9. And then when we're dividing, what do you do the powers? You subtract the powers, right? So 6 minus 4 is 2. I have b3 divided by b3. Now, if it's the same thing over the same thing, that's 1, right? Or if you subtract the powers, 3 minus 3 is 0, so b to the power 0. Well, anything to the power 0 is just going to be a 1. So if you want to put a 1 here, you can. And then finally, you have a c3 there by itself. And the way I would just write this is just 9a squared c3. So there's your final answer if you write it out, if you write it all out. Okay, let's move on to some of the last two questions here. Just some BEDMAS questions here. Always do the brackets first. So here's a bracket. What's 15 minus 5? So 15 minus 5 is going to be 10 minus, what's 1 plus 3? Well, 1 plus 3 is going to be 4. And then you have this, 1 plus 3 is 4, and you have power 2 there. And then you have this big bracket there with the 3 and the 10 plus. Okay, from there, keep on going to the brackets here. So this 10 will remain. So 10 minus, what's 4 to the power 2? Well, 4 to the power 2 is going to be 16. Right, so 4 to the power 2 is going to be 16. Then ask yourself, what is 10 minus 16? Well, 10 minus 16 is going to be negative 6. And 10, and then from there, what is positive 3 times negative 6? Well, that's going to be negative 18. So 10 minus 18 is going to be negative 8. So there's your final answer for that one. All right, last one here. Let's go ahead and do the BEDMAS here. So 12 plus 3. Well, what's 12 plus 3? 12 plus 3 is going to be 15. So 15 divided by 5. And then you have this minus 1 and this 2 times 5 minus, right? So let's just do BEDMAS first. So BEDMAS means you do multiplication division first. So make sure you take care of those first. So 2 times 5 is 10 minus, well, 15 divided by 5 is going to be 3, and then you have this minus 1 at the very end. All right, so 10 minus 3 is going to be 7, then minus the 1, and that will give you a 6.